Hello everyone, and welcome back to this third course in our introduction to artificial intelligence. In the first lecture, we talk about machine learning, system expert, fuzzy system, and we saw different application of artificial intelligence. So we focus on artificial intelligence through time to understand how we pass from system expert and hard coding some rules to machine learning stuff and how we use artificial intelligence today. In second course, we talk about what's the difference between machine learning and deep learning. We saw that deep learning was learning algorithm for machine learning, the same as linear model, tree-based model, and distance model. And in this third course, we will talk about the machine learning tools, the tools you need to know and you need to use to construct and develop artificial intelligence application and to become data scientist, data engineer, and to work in company to build the next AI application. So the first thing we will talk about is language, because there is most of the time the first question: which language I have to know to start working in the data world and build your first artificial intelligence application. I found very recently this website that compile like 500,000 jobs and to see the different language tools, database, the cloud library and framework used by some data guys. Here we are talk about more about data scientists, because the lecture is focused on data scientist jobs or people who are interested in artificial intelligence and machine learning, because like I said before, when we talk about artificial intelligence today, we mostly talk about machine learning, like 19% of the time, 90% of the time. So if we look at this graphic, we saw that in the majority of the case, you have to learn how to write on Python, and it's what I recommend to you, because the two main language in machine learning, artificial intelligence, data, what you want, is R and Python. Okay, why R? R, it's application software that been built by statistician, and at the start, people work in data were statistician. So they come from the mathematical world, the maths world, not from the informatics software engineering world. Okay, so they use R, which is very easy to use, very easy to learn and to make stuff, but it's not very easy to deploy and put in production. Okay, so nowadays every years more and more people learn Python. Now few people learn R. I think the 40% of the people here are in companies that are using R. So you have to know both of them, but I think in 10 years, I think it will be mostly Python that we will use, to build artificial intelligence application. So why Python? It's because it's easy to learn, is easy to read. People who don't know Python the language but know how to make development or code in other language can read it very easily. It's compatible with wide range of platform, but the main reason is there is numerous package optimized for data science. R2 is because it's for that is the second language in artificial intelligence and machine learning, but the package now in Python is now better than in R. You can make deep learning in Python, and not so much in R. You can make parallelism computation, and not with R. So yeah, now if you want to make serious work in artificial intelligence, you have to use Python. And I will speak about different package you need to learn to become data scientist, or to better understand what type of packages people who work for you have to learn to build artificial intelligence software. The first one is NumPy. NumPy is a Python library that provides a simple yet powerful data structure in n-dimensional array. Is the foundation of on which almost all the power of Python data science toolkits is built. And learning NumPy is the first step of any Python data scientist journey. So I recommend to learn how to use NumPy. So here's the top 4 benefits that NumPy can bring to your code. More speed. NumPy uses algorithm written in C that completes in nanosecond rather than second, because I think I bet you know, but Python is a slow language, but NumPy is written in C, so it's very you can have more speed to use NumPy than use Python, standard Python. Fewer loop. NumPy helps to reduce loop and keep getting tangled in iteration indices. Clearer code. Without loop, your code will look more like equation you are trying to calculate. So if you want to pass from mathematical aspects to the code, NumPy helps you to keep more readability and better quality. There are thousands of contributors that are working to keep NumPy fast, friendly, and bug-free. The second is pandas. It's the same that NumPy. NumPy you can handle mathematical aspect and handle scalar, matrix, and tensor. So every kind of data you want to use, which is unstructured or structure or whatever. Pandas is specialized in structured data. So Panda is a Python library used for working with datasets. It has function for analyzing, cleaning, and exploring and manipulating data, and especially data frame and data in table. So quick note that the name Pandas has reference to both panel data and Python data analysis. So this is why it is Panda. So Pandas allows us to analyze big data and make conclusions based on statistical theory. Pandas clean messy dataset and make them readable and relevant. And relevance data is very important in data science. Data science, because if your data is in low quality, your model and your artificial intelligence application will be in low quality too. So Panda has the difference and several key benefits to data scientists and developers, like including easily handling of missing data in both floating point and non-floating point data. Size mutability. Column can be inserted, delayed from data frame in higher dimension object. It is there is a group by functionality. So it's a powerful and flexible group by functionality to perform split, apply, combine operation on datasets for both aggregating and transforming data. And intelligence level based slicing, fancy indexing and subsetting of large datasets, intuitive merging and joining datasets, and flexible reshaping and pivoting on datasets. The third is Matplotlib. So now you can handle data, pandas with structured data into data frame, and NumPy for unstructured data if it's sound, images, videos, etc., etc. Matplotlib can help you modelize, visualize your data that you can handle, because it's difficult to represent data and to understand your data sets when it's on NumPy. Matplotlib help you to animate and more understand your data. So Matplotlib is a comprehensive library for creating static, animated, and interactive visualization in Python. So Matplotlib make easy and hard thing possible. So you can create publication quality plots, make interactive figures. I can zoom, pan, and update, customizing visual style and layouts, export MIDI file formats, embed in Jupyter Notebook and graphical user interface, and use rich array and third-party package to build a Matplotlib. And what I wanted to show you, yeah, in fact, with Matplotlib you can visualize your data from in a lot of different way. Pairwise data, statistical distribution, grade data, regularly grade data, and 3D volumetric data. And when you want to, I don't know, like use Skater they have lot of different parameters, and it's sometimes difficult to have a great and beautiful visualization, like the visualization that you can see here. It can be very flexible but very difficult to make. A little trick that I do now, if you go to ChatGPT and you ask ChatGPT, okay, I have this kind of data, I want to make a beautiful Matplotlib representation, visualization in Python, give me the code, and ChatGPT can make most of the code to make a good visualization of your data. So yeah, keep in mind, because every time I want to plot, I pass a lot of time reading the documentation again and again and again, and using ChatGPT can help you a lot for that. Okay. So the next one is scikit-learn. So scikit-learn is the most useful and robust library for machine learning in Python. It provides a selection of efficient tools for machine learning and statistical modeling, including classification, regression, dimensional reduction, and clustering. And this library is largely written in Python, built on NumPy, SciPy, and Matplotlib. So the libraries that we saw earlier. And so we saw that with scikit-learn you can address all the different category of problems that we can find in machine learning. You saw that I said there machine learning there is two problems. Supervised learning and unsupervised learning, and these two problems are subdivided in classification, regression, and clustering, and dimensional regression. And you can find a lot of different learning algorithm here to solve every problem. So for classification, you can use different algorithm, and even here they are not all listed. If you go to the scikit-learn documentation, here, and for example I want to solve a regression problem, here in linear problem we have all this model. And here for supervised learning, you have all this model to solve your problem. Okay, so it's mostly scikit-learn that's made Python the best language of programming language to solve artificial intelligence problem. But as we can see, there is a lot of learning algorithms solve classification, regression, clustering, or dimensional regression, but it's for classical machine learning. It's not if you want to use deep learning algorithm, you cannot use scikit-learn. So if scikit-learn is just for classical machine learning, okay, it's very interesting. It's very very interesting. All people want to solve classical machine learning tasks use scikit-learn, but when you go to deep learning, it's not included in scikit-learn. You have to use two different package if you want to go to deep learning. In one hand you have TensorFlow, and in other hand you have PyTorch. So TensorFlow is open source but powered initially by Google, and PyTorch is also open source and sponsored and powered by Facebook. But at the start, TensorFlow and PyTorch are kinda difficult to use for people that's starting in data science and machine learning. Okay, so some people build top package that integrates TensorFlow, like Keras. Keras is it's a library that uses TensorFlow to train algorithm in very efficient way and very with like few line of codes. So if you want to train like classical algorithm or problems that are solved like 10 years ago about, I don't know, classification of image, or I don't know, you will find a lot of resources in Keras, and in 2 or 3 lines of code you can train your model. Okay, and you have the same for PyTorch with fast.ai. I recommend to you to use more Keras than TensorFlow than PyTorch. Why? Is because the community in TensorFlow are greater. So if you it's more used by industry. It depends of you. In fact, if you are in industry, in company, most of the time I recommend to use TensorFlow and Keras, because if you have a problem, another person in the world had the same problem earlier and posted in the TensorFlow forum. And if not, there is a lot of people that look at forum about TensorFlow and are happy to help you. PyTorch, the community improve each year. So each year it become bigger and bigger and bigger. But it's mostly for research. So sometime in some file in research, in some field, everyone use PyTorch. I heard about, but mostly if you are in industry company, TensorFlow and Keras is better. And if you use in cloud, Google Cloud Platform, the GPU and Tensor Precise Unit TPU are efficient and more efficient to use TensorFlow than PyTorch. So it's finished. It's done for the Python the package. For the second language you need to know is SQL. SQL, it's a language that will use to extract information from database. Okay. The idea is to extract information from database, and if you don't know well how to use SQL, and if you don't extract the right data, or you made a mistake, or I don't know, you only extract a subset of data, all your projects will be doomed to lose. Because if you don't have the right data, your model will never be performant or accurate. Okay, so has use SQL to create your data sets to train your model. If you don't have the right skill in extracting your data, even if you are the best data scientist in the world, you will not achieve to create data model that can accurately solve your problem. So focus on Python and SQL, and it's for that like most of the time for the scientist you will need SQL and Python, both of them. Okay. And when you write code, your code will change during all the time when you will train your model, when you will make the processing and you will prepare your data. You will have to write code, and the code evolves through time. And you need to use a software to easily save your code and version your code to be sure that you can go through time to maybe you create new features and it lead to an error and you don't know why, and you don't achieve to solve the problem. With GitHub you can return into an earlier version of your code that still works. So versioning is an important feature when you are coding a software. So GitHub allows collaboration with developers from all over the world. It's an open source solution. Like GitHub enables potential developers to contribute and share the knowledge to benefit the global community. And GitHub is easy for project management. So GitHub is a place to where Project manager and developer come together to coordinate, track, and update their work so that projects are transparent and stay on schedule. That is very important with artificial intelligence problems. They can't sometimes take a long time to have an accurate model. Increase safety with package. Package can be published privately within the team or publicly with open source community. The package can be used or reused by downloading them on GitHub. Effective team management. GitHub helps all the team members to stay on the same page and organize. Moderation tools like issue and pull request locking helps the team to focus on the code. That improves the code writing. Pull requests. So when we make pull requests, you ask for other developer to review your code and see if there is no mistake, and it helps people to exchange about code and to be sure that you have the greatest quality of code in your project. So pull request help the organization to review, develop, and propose new code. Team members can discuss any implementation or proposal through there before changing the source code. That increase the cost safely. So GitHub use dedicated tool to identify and analyze vulnerability to the code that other tools tend to miss it. Development team everywhere work together to secure the software supply chain from the start to the finished. And at last, easy code hosting, so all the code and documentation are in one place. So there are millions of repositories on GitHub, and each repository has its own tools to help you host and release your code. But when you write your code and you save it on GitHub, and I don't know, you work on a project or with a small team, if another team of your company wants to say, oh, okay, your model is cool, I maybe need to use it. He download your code, but he cannot achieve to make it work because he don't have the same packages, the same version of packages, or he lacks. There is lack of dependency. So you need to have a confined environment to be sure that anybody in the world download your code, download the environments or the version of your package and dependencies, and achieve to make your code work. For that, you can use Poetry. Poetry is a modern dependency management and packaging tool for Python. It offers a more user-friendly approach and simplifies the process of managing dependency and projects. Poetry replaces the need for multiple files like setup.py or requirement.txt or setup.cfg and pipeline, makefile, dependency software, etc., etc. Here is more straightforward. You just need to install and use Poetry. It will replace all the dependency and all the environment thing. So Poetry makes dependency management. So pip requires some manual configuration to use at maximum efficiency. Poetry aims to dispel this and be more user-friendly, and so the command task will be more simple. A better resolver, so Poetry had more advanced dependency resolution, so it can handle conflicts and more effectively, and does not lead to issue in version pinning. It has a virtual environment, like I said before. Poetry use a built-in virtual environment, which is easier to configure, whereas both pip and pipeenv relive on the venv model, which could be slightly cumbersome to be set up. Actively update, since it's newer, Poetry is actively developed and managed, so frequent bug fix and update more functionality. And packaging. It's easier to manage packages that have been created with Poetry than pipe. and it contains several built-in commands that make it very easier to handle packages, so it saves time in the long run. So in the past I use lots pyenv and venv, but in the recent months I found Poetry, and it's very better to be sure that your environment is secure and you can share with other people in the world your code, and be sure that anybody can use it. As the last tool I want to speak to you is the cloud computing, because it's like today it's inevitable. Everybody use cloud computing. Why? It's because like it's very easy to regroup all the things in the same place. And also you could use the cloud you can use the per use model is good for busty AI or machine learning workload, because during your training maybe you need, I don't know, 100 GPU to train your model, and after when you will after the training to use your model, you will only use, I don't know, some CPU, and that's all. So if you had to buy all the GPU just for one training, it's worthless. So yeah, the pay per use is very interesting. In artificial intelligence, it's a must-have. The cloud makes it easier for enterprise to experiment with machine learning capabilities and scale up as the project go into production and demand increase. The cloud makes intelligent capability accessible without requiring advanced skill in artificial intelligence or data science, and cloud provider offer many machine learning options that don't require deep knowledge of AI, machine learning theory, or team of data scientists. So there is the machine learning classic workflows. You have a source and prepare your data. You train, evaluate, and tune your model. You develop your train model here. Here you get prediction from your model. You monitor your ongoing prediction, and you manage your model and version. And all the thing here can be included in your in cloud. Cloud include all of this workflow and very easily. You can monitor your costs and understand billing, rationalize the cost, avoid unnecessary expense. Today there is a different cloud leader. There is a Google Cloud Platform, so GCP, Amazon Web Services, AWS, Microsoft Azure, and a new challenger, which is OVH Cloud. So Amazon Web Services is a leader of the market with 30% of the market. So yeah, the AI there is some AI that are available for the developers, so you don't need to have a deep understanding in artificial intelligence to use them. In computer vision, in video and image analysis, failure detection, natural language processing, so in information extraction, chatbots, so improve the experience, customer experience, so in information retrieval, online experience, for the business KPI like forecast, fraud detection, etc. If you are if you have a company that sold a lot of product in your website, I recommend you to add Amazon Web Services, because there is a lot of tools for a commercial approach. And if you have Amazon Web Services, you maybe want to hire people that handle well this platform, and with the AWS certified specialty, you can recruit easily some people that are certified and formed to create your process and products on Amazon Web Services. The second is Microsoft Azure with 19% of the market. Azure is connective, have also a model on the shelf with Azure Cognitive Service like Speech API, Language API, Vision API, and Decision API. And it's the more secure cloud. It's focused on safety and the only one to have HDS certification in France to work with critical data to health, finance, etc. Also, you can find some specialists with Microsoft certified. You have also Google Cloud Platform. It had only 7% of the market, but last year have a growth of 130%, and now like a lot of new company gets firstly to Google Cloud Platform, and I heard currently that a lot of big companies switch to Google Cloud Platform. They also have AI for Dev, like AutoML, Cloud Natural Language, Dialogflow, media translation, speech to text, text to speech, AI translation, AI in video, invasion, and a lot of tools for structuring your data. There is a pay as you go, no initial cost, and average it's cheaper. There is no consultant fee, and you find specialists. But why a lot of people go to Google Cloud Platform? Because it had a thing that is there is a services that's only Google have. It's called BigQuery. It is for big data company, and it can manage to process terabyte of data in only some seconds or minutes, and it's a very big server that can process a terabyte of data in order of second of minutes, and it's only Google that can give you these services. The last one I wanted to talk is OVH Cloud. It's not well known, except in France and some country in Europe. Is an advantage in Europe. It's advantage because it's in Europe, so it's better GDPR compliance for general data protection regulation. There are more confidence in management of sensitive data. It's sponsorship of Europe, and it's a challenger, so therefore more accessible to partnership and often cheaper than the three other. So it's a new challenger, so also interesting, but it's still a lag for behind this competitor. There is no certification and no differentiation in this offer. So ultimately, which one to choose? The offering of the big three cloud provider don't differ much, in fact. Except with Google Cloud Platform with BigQuery, you will find the same thing in AWS and Azure. They try to differentiate themselves on some specification, but the classic application remain equivalent. At the moment, so GCP is making a lot of noise with BigQuery, which offer unrivaled scalability in Azure and AWS. And also, IAVH is trying to enter into the market. It's not mature yet, so I don't recommend it at the moment. So it's all for this talk about tools for data science and for artificial intelligence. I hope you enjoy it. Bye.